Hello, my name is Aaron, and today I'll be showing you guys how to use TMA-Grid to de-array a whole slide image. To start with, we'll upload a file either from our local computers, from an image URL, or by logging into Box. Now we'll be using the demo image today from the Harvard Dataverse. So once the image loads, we can click Proceed to go on to the Segmentation tab. What you're looking at here is a segmentation mask generated by a convolutional neural network that's running locally on your computer. There's a couple of parameters to note here that we can adjust, such as the sensitivity. Increasing the sensitivity will allow the neural network to pick up more area as tissue. Conversely, decreasing the sensitivity will make it so that the network is more picky about which areas to label as tissue. We can also adjust the transparency of the mask. So by increasing the alpha value, the mask becomes less transparent, and by decreasing the alpha value, the mask becomes more transparent. On this screen, we can also specify the minimum and maximum areas of tissue that we consider a core. We can also add cores by clicking on the segmentation mask directly, like so, and we can also remove cores by holding the Shift button and clicking on any blue dots that we want to remove, like so. So we'll just add in a couple missing cores. Alright, when we feel like we've gotten most of the cores, we can click the Proceed button to move on to the Gridding tab. The first thing you'll notice on the Gridding tab is that there are a bunch of different color-coded circles. Now, as shown in the legend below, the green circles indicate the marker cores, the blue circles indicate the normal cores, the red circles the misaligned cores, and none of them are significantly misaligned right now. But if I drag this outside of the expected grid configuration, you'll see that this is marked in red now. And the orange cores are the imaginary cores, or the cores we consider missing or abnormal. And we can toggle between cores that we consider abnormal versus normal by holding the Shift button and clicking on the core we want to toggle. Now, as you can see, when I click on this core, it turned from yellow to blue, and if I click on it again, it turns back to yellow. So we can zoom in and out of this whole slide image viewer, and as you can see here, it works extremely smoothly, even though this image is stored on Google and not on our local device. Now we can edit each of these cores by simply clicking and dragging. We can resize them by clicking, and these little anchor points will pop up in the four corners, and we can drag to resize to make it bigger or smaller. And if we wanted to adjust the parameters, we can click on the menu bar on the left side, and here we can, increase the size of all the cores, decrease the size of all the cores. We can adjust the image's rotation, and once we adjust the rotation, we can click the apply button, and it would rerun the gridding algorithm based on the new rotation. So let's go back to 0 for now. We can also choose to not connect the cores by unclicking this box. And now if we click apply, the lines between all the cores are gone. We can also open up the advanced settings here, and you'll see all of these different parameters that are hidden by default. Now, if you want to learn more about these advanced settings, I highly recommend you take a look at our manuscript, and I'll post that down below in the video once the manuscript is out. An extremely important feature to note here is the auto row/column checkbox. So when we check this checkbox right here and we drag a core, let's say this core down over here, it will automatically determine what the row and column values are. You can see here all the cores in the second row got renumbered since I dragged this core from the first row down. And if we moved it back, it would automatically renumber all of the cores that were modified or affected. Now, if we uncheck this checkbox, this feature would be turned off, and we could keep the original numbering of the cores no matter where we dragged it. Now, why is this feature relevant? Well, if we just click to proceed right now, we'll see that we get an error message that says that we have to assign row and column indices to the green marker cores, because without assigning them row and indices values, they will not show up in the next screen, in the virtual grid screen. So if we click on the marker core, we have to uncheck the is a marker checkbox, and that would automatically turn off auto row/column if it was on. And let's say we wanted to assign this to the first row. Let's say first row 16th column. If we press save, now you'll see that the original core, which was at the first row and 16th column, it got a little bit messed up because when you assign a row column indice to a core that already exists, it sort of swaps the cores. In order to fix this error, all we have to do is turn on auto row and column and then just slightly move this around, and it will automatically reassign the row and column indices to all the cores. And to avoid that issue, all we have to do is just to assign this core to a row and column that doesn't yet exist. So let's say 217. Now I didn't have to add in that extra step of adjusting the cores, but let's say you do want this to be row 2 column 1. We can turn on auto row / column here and adjust it slightly so it renumbers everything. And we'll just sort of do the same thing for this last core. Let's assign this to row 2 column 17. And then we'll turn on auto row / column and wiggle it around slightly so that all the values get reset. Okay, so now that we've assigned values to all the marker cores, we can click on the Proceed tab to go on to the Virtual Grid tab. So as you can see in the Virtual Grid tab, we get an idealized grid that shows a preview of what the de-arrayed results look like. If we clicked on any of the cores, we can edit their associated metadata. As you can see here, the metadata so far contains the X and Y coordinate values, the columns, the rows, the current radius, whether they're imaginary or not. And if you ever wanted to add a new field, all we have to do is click the Add Field button. We can enter a name for this field. For example, let's say has cancer cells. No. And once we click Update Metadata, this has cancer cell field will get added to every single one of the cores within the grid. Now, if we wanted to export the metadata, all we have to do is click this metadata JSON or metadata CSV file, and that will either export it as a JSON file or a CSV file. So once we open the CSV file, we can see the metadata for every single core with the new field has cancer cells. And if we ever wanted to just download the full resolution image of a single core, all we have to do is double click on that core, and in a second, this full resolution version of the image will pop up right here. If we wanted to export all the cores at once, we just have to click on the Export Grid button, and this will bring you to select the folder that you want to download the file to, and we could go to Downloads, create a new folder called Saved Cores, create, select the folder, and it would ask you whether we have permissions to view files and save files in the folder. Just click View Files and allow the site to save changes, and the download process will start to begin. And notice that we are downloading a huge multi-gigabyte image, so this process will take a while depending on your internet speed. As you can see, all the cores are being downloaded in real time. Once the exporting is done, you'll see all the 211 cores in the folder that you've specified. You can open up any of these cores, and they're all numbered with the row and column indices of each core, with the row being the first number and the column being the second number. And if you're having trouble remembering any of these instructions that I'm giving you today, you can always click the top right corner of the web page for a quick reminder. Anyways, thank you guys so much for watching, and I hope you guys find TMA-Grid useful in your work.